afternoon. I'm Francis Levy, co-director of the Philoctetes Center. Ed Nersessian is the other co-director. And welcome to the role of subject in science. I just wanted to say that this particular roundtable, as all our roundtables, is being broadcast via internet throughout the world. So anybody going to the Philoctetes site can see this particular roundtable. I am now pleased to introduce Piet, who previously appeared at Philoctetes as a member of the Modern Cosmology panel. Piet is professor at the Institute of Advanced Study, where he heads the program of interdisciplinary studies. An astrophysicist with an interest in the history of the universe and computational science, he is the author of many books and articles that explore these areas. Professor Hut will moderate this afternoon's panel and introduce the other panelists. Thank you.
Thank you very much, and thank you all for coming here. It is wonderful to be back. I was here half a year ago in the Cosmology Roundtable. That was my debut here, and I really enjoyed it so much. I immediately suggested a new topic, which they happily accepted, and here we are again about the science of the subject. So to introduce my colleagues here, Margaret Turnbull is an astrobiologist. And if you want to know what an astrobiologist is, you can ask her later and she'll probably tell you. She is at the Space Telescope Science Institute in Baltimore. Sukanya Chakrabarti is at Harvard. She is an astrophysicist and she studies spiral galaxies. If you want to know why galaxies have spirals, she is the woman to ask. Then Jan Schwindt is from Germany, from Heidelberg, the University of Heidelberg, where he works as a theoretical physicist on the nature of quantum gravity. If you want to know what things are deep, deep down in subatomic structure, he can speculate about it. Ed Turner is a fellow Princetonian from the university, Princeton University, an astrophysicist who works on many, many different topics, all within astrophysics. So thank you all for joining me here. And just to introduce the topic briefly, you saw the little paragraph which we wrote. Actually, it took us a few weeks to write that paragraph. We were all in different places and we were sending email and we already got into a heated discussion what the paragraph would be. So it seems an innocent paragraph, but each word had some fighting behind it. Actually, yesterday we all met in Princeton for another warm-up, so we are really excited about the topic and we are ready to go full steam ahead. But again, just to put the topic on the round table here, if I give a personal twist to it, when I was 17 and I had to decide what to take as my major for going to college the year afterwards, I decided to go into astrophysics. And one of the reasons to take physics, or astrophysics in particular, was that the whole notion of unification, of connection, of transformation really appealed to me. Here in front of you, you see ice floating in water, and the ice and the water look so different, but the physics analysis shows that both of them are made from exactly the same H2O molecules, and you can transform them because you take the same substance and you have a different configuration. So it seems like ice and water are different substances, but it's really a different configuration of the same substance. So the property difference between ice and water is space, not matter. The matter is the same, but a different spatial configuration. So it's a different use of space which makes ice being ice and water being water. And in a similar way, many other things have been unified in an unexpected way. Electricity and magnetism, space and time itself in relativity theory, matter and energy. What can be different from matter and energy? I mean, who would expect that they can transform into each other like ice and water? Those were the big surprises of physics in the last century and the last couple centuries. So naively, as a high school student eager to go into physics, naively I thought, well, space and time, matter and energy, what is the next thing? Each next unification thing which you can transform like water and ice is more unexpected. So obviously to me, the next thing would be matter and mind. The next physics step would be to let matter and mind transform in the next unified theory. But I realized very, very quickly as a freshman that if I would use the word mind, I would have to wash my mouth. I have to shut up. That would be so un-physics-like and unscientific. Really, that was a no-no. I'm talking about way back when in 1971 when I was a freshman. But throughout the 70s and most of the 80s, still at the coffee discussion in physics, if you would bring up consciousness or whatever, there would be sort of this silence, or you see people getting their, what is the English word, hackles up? Whatever was aggressive, it came out. And obviously that was not the right thing to do. But for whatever reasons, in the 90s, fortunately, consciousness became more and more something you could talk about. People were not really comfortable with it. There was a change of the guards, people retiring, people starting to write about this. Anyway, the atmosphere became such that it became a little bit possible to talk about it. So, as part of that wave, we are here together to talk about the role of the subject. And why subject? Well, science prides itself on being empirical. Physics and all natural sciences are based on experiment. And experiment is a systematic form of experience. We don't want to speculate. We like to guess, that is called theory. Then we like to have experience about the matter through experiments. Through a guess, through a theory, you design an experiment. From the outcome of the experiment, you can refine the theory. With a better theory, you can define more refined experiments. And this circle of theory and experiments refines your knowledge. But ultimately, everything is tested on experiments. But the experience we use in doing experiments, every experience has a subject and an object. I see a table, I drink water, you hear me, etc. There is a subject and an object and an interaction. Now, starting with Galileo, what science has done for the last 400 years is only to take the object pole and to describe everything as objects. And the scientist who does science, who does experiments, the scientist steps behind the camera, is not visible, the subject is being taken out, and when different subjects agree, that agreed upon object is part of science. So in the experience relation subject, interaction, object, it is only the object pole which has been made into, as building block, as the only building block of 400 years of science. But there are some signs, we think, that we have run out of steam with only using the object pole. Maybe we have to take the subject and the interaction part on an equal level as the object part. And some signs for the reasons to do this is that there are areas in science like quantum mechanics, like neuroscience, like robotics, where a purely objective approach seems to fail, seems not to be good enough. If you take quantum mechanics, you can describe the behavior of an electron or a photon, any elementary particle, or sometimes even larger objects. And if you describe it, you can predict, if you measure it in a certain way, what the properties are. But if you measure it in a different way, you get different properties which are not compatible with the properties you measured in the first way. There is not one classical description which could explain all the different measurements. So in a way, by measuring it, you bring out the properties. There is an interaction between who measures and what is measured. So it doesn't fit in a purely object part. There is more of the subject-object ingredients. There is a wider empirical ingredients going in to quantum mechanics. That is one point. The second crack in the wall of a purely objective description is in neuroscience. If you study the brain with fMRI or whatever other methods, you can measure the electrical and chemical changes in the brain if you have particular experiences. So you can make a type of dictionary between personal, first-person experience and third-person objective description of chemical electrical processes. And the very fact that you can have a dictionary, at the one hand the objective description, and the other hand what you experience yourself, means that what you experience is something extra beyond the purely objective description. So there is the subject coming in the translation. And the third point, robotics, is another interesting area purely from engineering. And it is really surprising that if you look at science fiction books from 50 years ago, all the science fiction books predicted that in the year 2000 you would have robots cleaning your house, serving us drinks, greeting us at the door. And no book predicted that we would have personal computers. In fact, we have personal computers everywhere. Many of our pockets have personal computers which can do web browsing, completely unpredicted. But where are the robots? We still have to do our own dishes, or at least put them in a dishwasher. And I think the reason is that science is still too much object-oriented. All of our 400 years of science is thinking in terms of objects, and if we want to build a robot, we try to build a very clever object. But we don't know enough about what the subject is to build a subject. Building a robot is really building a subject. And the material, wheels have been with us for a long time, motors have been with us, sensors have been with us for 100 years. All the hardware of a robot is easy to build. But we still don't know how to imagine, to take the Philoctetes term, how to imagine what it is like to be a subject, and therefore how to build a robot in our own image, so to speak. So these three examples are examples of why we think purely object-centered science is not good enough. We have to extend it and somehow get a unification of the object and the subject. So that will be the topic of the rest of the discussion. I think it will be nice if we go around the circle and each of us tell a little bit of where we are coming from. Why are we interested in this topic? So we will first leave the Earth and go to astrobiologist Margaret.
So I guess my entry point into this discussion is partially, at least, from the perspective of someone trying to find herself among the stars. And my background is one of my backgrounds is in SETI, the search for extraterrestrial intelligence, and so I'm very familiar with this desire to find out if we are the only intelligent civilization in the universe, or are there others out there that we can communicate with. And I remember one point I was at the telescope and with my advisor who was really running this SETI project, and we were in Puerto Rico at the big radio dish, and I was just sitting there and we were going all night long, looking at different stars, listening for signals, and I had this vision of us from afar, looking down on the earth, and us in our little chairs in front of our little computer screens and our little radio dish, pointing out into the universe and searching and searching and searching. And Earth is so little, so little, and we're so small, and the universe is so vast. And it just seemed like such a hopeful thing for these little people to be searching this incredibly vast universe for any sign of whether or not, is there anybody else out there? And I felt such compassion for those people on this planet, wondering this question, are we the only ones in the whole universe? So I think that was sort of my first glimpse of, looking at myself, who I am the subject, but sort of stepping outside and looking back at the subjects and seeing the subjects. And I felt the result of that was that I felt not only could I see a different perspective on this whole situation, but I felt a real sense of empathy and compassion for the thing that I was looking at. And this is something that I think that this dichotomy, subject-object dichotomy, is something that's beginning to break down in many areas of science, as you started to describe. And the desire to find life on other planets is really, I think, going to bring that home for us, because we're trying to literally find ourselves among the stars, and as a result, we need to know, just even for practical considerations, what do we look like from far away. So we're beginning to turn our telescopes around and look at our own planet and say, what does our living planet look like, so that we can then learn how to find other living planets around other stars and see how to tune our telescopes so that we'll be able to detect those kinds of signals. But that's one example of how going out into the universe is bringing our thought back home and causing us to take a look at ourselves and what are we exactly, and how do we impact the universe even as we study it.
So one of the reasons I've been interested in this idea of the subject-object distinction is that it seems that it can possibly give us some extra degrees of freedom, some extra understanding in the way that Piet alluded to when in terms of the discoveries of quantum mechanics and wave-particle duality, where earlier these things were thought of as being mutually exclusive. To give you sort of a tangible example of how I've thought of this, I did some exercises that Piet suggested, where I try to look at objects like this table or these paintings as subjects, where a subject is like ourselves. And one thing that I find very often when I do this, nearly always, is that I have a much greater sense, a much greater awareness of my environment. I notice these things in much more detail. So already you start to see, when you look at or try to see what you typically envision as an object, as a subject, you find some sort of extra degrees of freedom that you hadn't previously realized. And in this, there's sort of two aspects of the subject-object study that one could do. You can look at subjects as objects, which I find more difficult to do. But on the other hand, looking at objects as subjects, objects are sort of like impoverished subjects in some sense. That seems to me kind of a promising route for myself. And yeah, one of the things I've found generally is that I have a much greater awareness of the subject and of the environment, of my own environment, when I do these kind of exercises.
Okay, so my starting point for this was when I was a teenager. It was the first time that I was thinking about what is this science thing all about? Where can it lead us? Can we learn everything by science, or are there other ways of knowledge? And so I made two observations at that time. The first was science turns things into numbers. Today I would say mathematical structures, because this is what theoretical physicists deal with. And the other observation was, I am not a number, or at least I seem to be not a number. And then the question was for me, so if I'm not a number, so what then am I? And how can science be used? Can I use science to answer these questions, or do I need something else than science? And I try to follow this question as far as possible. And so I still don't know where this all leads me to, but yeah, it's basically the question, who am I, which led me to think about these things.
Maybe I should start by praising Caesar before we kill him, by saying that as an astronomer or an astrophysicist, is one part of science that has really illustrated the incredible power of the subject-object split. That is to say, we just look at lights moving in the night sky, basically. And by applying this subject-object split, we've produced this wonderfully rich tale of understanding the universe in just a few centuries, far beyond anything people could have imagined. If you now, brought in a group to talk, you had a group talk about cosmology, we could talk about the stars, we could talk about many things and tell you a very rich, detailed story about what's going on out there that produces our experience of it, which is, interesting, beautiful, but doesn't obviously contain all that richness behind it, all that rich stuff. And there are many things like that in science. The colors you see, we can analyze in terms of wavelengths and light and the structure of your eyes. It's been hugely powerful. And in a sense, my entry into this, one of my reasons for being interested in the subject-object split, is it has bumped its head on a couple of things that it's made no progress on. I would say there's a hole in the heart of physics, something which this approach of turning, treating things out in the world as subjects and then explaining our experiences in terms of a much richer, deeper story has totally failed on. And it's two of the most basic human experiences. The first is the experience of the moving now, the passage of time. Many physicists don't think about this, but most will immediately acknowledge it if you ask them the question. All the fundamental equations of physics are, just about all, have time as one of the variables in them. So they're all about time. But, in fact, they're almost all second-order differential equations, just to throw out the piece of jargon, a sort of particular type of equation that involves time. But not a single one of them, nowhere in our description of reality is any indication that there's a special moment, that there's a place in this, let's call it a dimension of time, corresponding to the now that moves on. And that's surely one of the most fundamental of human experiences. And there's not the, there's not the slightest hint of it in reductionist science. That in other words, if you told some imaginary being that didn't have a sense of time everything we know scientifically, they would never guess that we had the experience of now, or a passage of time, a moving now. And the second, maybe related, maybe not, is consciousness. Surely, in some sense, that's what we mean by having experiences that we're conscious of something. There's no hint in the equations of physics of any role for consciousness. It's so slippery that we couldn't even get hold of it. There's a familiar problem with saying, well, we can't really find out whether another person has self-consciousness. We only know our own. And you can, if I had a machine here, one of the computers or one of the robots that Piet referred to, and I said, oh, that's self-conscious. And Maggie said, no, that's not self-conscious. It's not just that we would disagree or that we could argue about it, but there isn't, as far as we know, even in principle, a way of resolving that question. There's anything we can get hold of is sort of by definition not the consciousness of the thing itself. And so let me not go on too long about this, but very powerful tools often impose very powerful limits on what you can learn. And I kind of have an intuition that the power of the subject-object split, which has allowed us to do so much in so many areas of science, to unwind these deep and explanatory tales about our experiences, perhaps that subject-object split we make as a technique for producing those things, it's not that helpful to understanding the stars to talk about how they look to you. You have to sort of remove yourself from the equation. It may also be limiting us, keeping us from understanding these other very fundamental experiences of the passage of time and consciousness. I would just pick those two out as the two walls off which the bullet of reductionist science is bounced without making, the slightest impression, I would say.
So we have cracks in the wall, but the bullets can't do anything. We like to mix our metaphors, as you can see. So that gave us a nice closure of the circle. Well, one of the things we have been talking about already by email and also yesterday is about what this may be for the future. In science is young. It is something which is very easy to forget, that science is a very young human activity. It's only 400 years old. There are roots in the Greeks and there are roots in Middle Ages and earlier, but the present way in which we do modern science, with peer review, with sort of an open source like publishing what you know and all of that, that strictly started around the time of Galileo, and it was only codified in a mathematically rigorous way with Newton, which is only 300 and a little bit years ago. So if you compare science and art, or science and religion, or science and philosophy, you're comparing this youngster, this new kid on the block, with something which is 10 times older or 1,000 times older. I mean, the oldest cave paintings are something like 30,000 years, so it's 100 times older than science is. So it is sort of an unequal discussion, and science often behaves like a rebellious teenager. who thinks that he knows everything about everything. So I tried to pick a few scientists who don't have that particular idea. We all admit that there are things we don't know, and we are happy to talk about that. So one of the things we talked about is what will happen in the next 400 years. We have had 400 years of science, of object-centered science. Could it be that the subject can come in an equal footing? Or could it be that we have a richer way of turning the subject into object? What would it mean to grapple with the subject? We don't know, obviously, otherwise we would publish interesting papers about that, but we can sort of guess in what direction you may want to look. So I don't know whether any of you want to talk about your speculations for the next few years or few hundred years.
Well, I would say an obstacle I see to that progression. Well, first of all, it would be the sort of realm of science has expanded and is expanding, and as Piet outlined in his initial comments, there are now fields of science that are being dragged almost involuntarily back to regard the subject. There also may be fundamental obstacles in that will require us to at least change, and there's a reference to that in our introductory paragraph, to relax or reduce the limitations we put on what kind of evidence is acceptable in science. Because if the subject is a subjective experience, if being a subject is a subjective experience, in some sense we may be, I'm making an almost trivial linguistic point now, but it sort of sounds like a play on words, but we maybe have to let evidence of a sort of different, fundamentally different character inside the tent of, and Piet and I have disagreed about whether it would still properly be called science, but that's a semantic point. Perhaps we could change the definition of what we call science, or we could come up with a new term, or we could discuss whether there even is such a fundamental difference. But one issue of moving forward in the direction of relying less, let us say, on the subject-object split, is what kind of evidence is going to be acceptable as a part of the body of science, and whether we have to change that over time. I think it has changed in the past, could change again, but there's a question of how fundamental and so on. I'm not sure I've made that very clear. But basically it comes down to the issue of, will we have to deal with subjective experience in some way or the other in order to make progress?
Well, one of the areas...
Oh, go ahead.
I was going to say, one of the areas that I think we're going to be quickly approaching this question from is that of healthcare, and the issue of how to care for the body and the connection between body and mind. I mean, we tend to really approach the body as this machine that is separate from this sort of ethereal awareness that lives and is trapped inside of it. And we're very, very young in our exploration, I think, at least in mainstream America, of whether or not there is any relationship between thought and the body, not just thought and experience, but also that experience including the body that you live in. And I would actually say that the way things are going right now with healthcare, the healthcare system in our country is going to drive us to a deeper understanding, because it's inevitable that looking at the body as a machine, that you just tweak this little thing, add this little bit of ingredients here, take this pill, do that, and it's fixed, is not going to work and is not a sustainable solution for us or for our well-being. So, and I have no experience of that, so it's hard for me to know about that. Whether mind, part of the definition of mind includes a sense of individuality and a sense of body.
I'm talking about without cerebral hemispheres. Is there a mind?
Maybe we should keep the questions for later. I've been instructed that the first hour we will talk among each other and then we open the floor.
We'll save that. Yeah. But I do feel that the current way things are going right now is, I can't prove what is going to happen in the future, but I will put my reputation on the table and make a prophecy that the current situation is not sustainable, and we're going to need to explore other avenues for healthcare that involve more a deeper understanding of mind.
Well, in terms of putting or introducing new things under the tent of science, I think sort of the fabric of science is very expandable and malleable and whatnot. And new sciences always, generally, the holy grail of science is ultimately to make predictions. But new sciences are not, when they begin, are not always successful immediately at making predictions. Of course, something like how do things act under gravity. That's something I can predict exactly. But that has taken, years to develop. But things like looking at, when people do simulations of galaxies and gas flow in galaxies, that's still a fairly new field. And that field is really more at the level of doing explanations of observations, rather than really at the level of making predictions that always turn out to be correct, or more often than not turn out to be correct. So in general, I think that science is developed in a kind of phenomenological way initially, where your initial attempt is to try and explain things, or even before that, even more in a more preliminary way to describe things, and then to explain, and then ultimately to predict.
I'd like to go back to what you mentioned.
I think we...
No, I thought you were going to go around.
No.
Next hour.
We've done that.
One thing one should emphasize is that science does already study the subject in a certain way. Neuroscientists study the subject, and psychologists study the subject, and they use a certain kind of evidence for that. And these evidences are all so to take the example of neuroscientists, they study the subject in terms of certain objects. The objects are the neurons in the brain and their interactions and so on. And this is a very successful way to study the subject. We learned a lot about how we subjectively work in this way. And so maybe this is one thing I want to emphasize, that studying the subject in terms of objects is an ansatz to unify the subject with the object. But it's not... So what we are thinking about, I guess, is that there could be a different kind of ansatz, which tries to study the subject without referring to such a kind of decomposition. And my personal view is that this will be very difficult, because there are reasons why science studies things in terms of objects, as Ed already mentioned. And these reasons are that science is about public things. So science, doing an experiment, means to do something which can be repeated, and where the results of the experiment are publicly available. And it's about experiences which are really which can be seen by everybody who wants to do the same experiment. So, and even the result of the experiment should be in a way that it can be, you will get the same result if you do the same experiment at a different place and under different circumstances. And this is something which I think is fundamental to science. So it will be very difficult to include these qualia-like things, these experiential things, understudy themselves in a scientific way.
Well, and maybe, while science, I think, has not tried to incorporate subjective experience, or actually has made progress by excluding subjective experience as a valid sort of data, or there certainly are traditions. Piet mentioned the fact that science, as we currently understand, it's a pretty young enterprise there, and all of us on the Roundtable here, actually, as it turns out, have some involvement with some sort of meditative tradition, and there certainly are meditative traditions, say in Eastern religions and other things too, where they have made the systematic use of their sort of systematic programs. And a perhaps well-known example is koan study in Zen Buddhism, where there's a sequence of exercises that the person goes through that are supposed to produce subjective experiences, not public experiences, but very important subjective experiences that are duplicates of what
study did you say? Who study?
This is koan study in Zen Buddhism. There's these, like the famous one is what's the sound of one hand clapping, but they're sort of little programs, almost like courses you can take, where you meditate on the whole series of these, and it's supposed to produce a predictable insight and result for the student. And it's not, in some ways, structurally all that different from the study of science. They say you go to the monastery and you go through this text of koans and you'll understand this, and I say, come to Princeton, pay our very reasonable tuition, and go through a study of these courses in mathematics and physics, and at the end you'll understand X, which everybody that goes through that, or most people that go through that, end up with that understanding. So I'm sort of now the goal of Buddhist study or Zen study, most of these traditions, is sort of personal growth, I would say, or something. It's for the benefit of the person. It's not a course of study that's designed to teach us something more about the nature of reality or something than we know now. But I no need to put words in his mouth since Piet's right here. But I think the kind of thing I imagine when I hear Piet talk about the future of science and the sort of increase in it, broad opening the tent to new types of things, you could imagine some sort of systemization of subjective experience that isn't public, but still leads the people that are willing to follow it to some sort of predictable understanding of.
Yeah, I certainly think that is possible. This image of the tent, I just thought about all of us like camels coming with our nose in the science tent. But I think even within science, science is using mathematics, especially physics, but most areas of science in some way. And we have the feeling that mathematics is objective. But what is objective about mathematics? You can open a book, there are words, and everybody can read the words. There are figures, everybody can trace the figures, the triangles, the lines. And the ink is objective, and the triangles are objective, and the words are objective. But unless you study mathematics for quite a number of years, you will not be able to make any sense out of graduate textbooks in mathematics. So you have to fall into the proof of a mathematical theorem. And you have to study it, and then you fall into it. It is your subjective experience. And then you learn, you see something, and you can talk with other people who also fell into it. And then, lo and behold, there is a community of people who talk this gibberish for other people about what these little pictures can mean. And they talk about transcendent equations and hyper this and who knows what. And they seem to understand each other, and they have a great time, and they derive new pictures, and they increase their knowledge. And it doesn't seem to make any sense from the outside. But the objectivity is not objectivity in the way we normally think. It is intersubjectivity, I would say, and everything which is called objective, if you really look at it, it is intersubjectivity, and there is a large enough community agreeing that this counts as objectivity. That's why peer review is so important in science. Individual scientists always go off in tangents, and some of them they just have to die out until science can make progress and the students are free to go into another direction. But ultimately, science as a body is this multi-generational growing body of knowledge, which seems to be quite resistant to the follies and the pride and the exterior motives of all the individual scientists playing the game. So there is something inter-scientist and inter-subjective which makes this quote-unquote objective enterprise work.
Yeah, I agree that. So, in fact, in the first place, even reading off a physical measuring device is in the first place a subjective experience. And only how we interpret this then, that we immediately see that this measuring device is an object. We consider it as an external object immediately. And we know that everybody else in the room would also see this object. But also, in the first place, it's a subjective experience. And also together with these immediately upcoming acknowledging that this is an object and that there are other people who would see the same thing. Only this makes it objective.
So would you say that it's the understanding of many minds, many separate consciousnesses that create objectivity by agreeing on what they're seeing?
I think one could see it that way, yeah. I mean, this existence of an external world, okay, it's obvious kind of a way, but when we do science, it is sufficient to say that I see something, the other guys would see the same thing, they would formulate it in the same way, and therefore it's objective.
It's interesting that we need so much training to be able to see it all in the same way. I mean, and the reason I bring this up is because I recently was, my home is in Wisconsin, and I go back pretty frequently just to visit family. And recently when I was back, an old friend of mine said, you have to come over to my apartment and watch this video with me because I have proof that there are aliens. All around the earth, visiting the earth. And I was like, in the interest of being somewhat open-minded, or just not even open-minded, okay, just fair, just wanting to to sit with my friend and see what he was seeing and try to make him understand, what I think of as the scientific perspective on this. I said, yes, let's go and watch this thing. So we went and did, and it was pure torture for me for about an hour and a half. But he had video footage of flying saucers coming in from the Earth, and this was NASA video footage of flying saucers with flashing lights, rotating discs, the whole deal, coming, basically just flying around all above Earth. And what it was a video of a tether experiment that was done. This was, Ed, you may know a little bit more about the particular experiment than I do, but apparently at one point a payload was taken into low Earth orbit and a long tether was released, and they wanted to see, when you're in free fall, basically, when you're in orbit around the Earth, how does an extended line like that behave? And I have no idea why they were doing this, but it doesn't matter. The point was, when they opened up the thing and the tether came out, to my eye, looking at this video, all kinds of debris immediately was released from that same container, and this, these little particles of dust and whatnot were out of focus because the camera was focused on the tether itself. And so as these little particles and whatnot came in and out of the focal plane, what happens is they become little donut-shaped things. and they're out of focus, and if they happen to be spinning, so that there's a light side and a dark side, this whole donut will appear to be flashing. And so these little donuts are going all over the place and they're flashing. And he's like, it's so obvious, can't you see that these are, he can't even comprehend. And I, with all my training and experience in imaging and optics and how, I've gone through this a million times with my own stellar targets. You've got to focus the telescope so that they don't look like donuts, they look like stars. And I was like, no, that's dust, that's debris. It's not flying flashing saucers, But he just, in order for us to be able, our two separate, perspectives, to be able to see the same thing, it was a whole body of experience and education that I brought with me, and that he had a different background. So we had two totally different experiences of that situation, and there was no meeting of minds that night. He was convinced that I was just brainwashed, basically. But yeah, this was so brainwashed that I couldn't even see what was right in front of my face on videotape.
And Maggie's story illustrates very vividly what a challenge it's going to be to let subjective experience inside the tent of science, because they're people that have all sorts of subjective experiences that they find extraordinarily, compelling, and a lot of the conventional progress science has been made exactly by the mechanism of being extremely hard-nosed about. In other words, unlike the question of whether the computer's conscious or not, the disagreement between Maggie and her friend could be resolved.
Eventually, yeah.
You could take him up in a spacecraft and let out a tether and let him see for himself.
Yes.
There's a clear way of that one could proceed to decide or convince a neutral party of which one of you was right, whether it was out of focus dust or advanced extraterrestrial vehicles causing the images. But what are we going to do with things where we can't think of a way of resolving the questions?
I think a way to get started would be to be very conservative and to look at the way objective science got started, the science of objects. If you look back at Galileo, what did he do? He took an object and dropped it, and he used his own he had his finger on his wrist to time how long it would take from different heights. And he had an inclined plane, and he let balls roll down the inclined plane. And he came up with a quadratic equation for the parabolic orbit of something you throw and which accelerates in its fall. So he took very, very simple pieces of objects and motions. And in Galileo's days, people had much more complicated things. They had ships moving, they had carts moving, they had cannonballs flying, and they knew about air friction. They knew that if you want to conquer a city, you don't shoot the cannonballs so that you make a nice parabola. They don't if there is air friction. It seems more like the cannonball is just flying and then it runs out of steam and it falls down. That is more or less what happens in first approximation. And if you're in a city, the cannonballs don't come from an angle, they come from the top because of the air friction. So Galileo knew that there was a lot of technology and empirical knowledge about very complicated orbits, but he chose something very simple just to get started, and he had this remarkable vision. Galileo had this vision, and he wrote it in his manifestos. Like, one day, if we start very, very simply, one day, if we just keep adding that over the generations, we may be able to understand more or less everything, at least more or less everything materially. And we have come a long way since him. It's just amazing that that vision worked out on such small beginnings. So my suggestion would be that if we look for a science of the subject, we don't try to explain the whole subject or anything subjective as a whole body. I think the key will be to find a few very, very simple experiments and very simple models to do something which we at least can agree upon, and then really describe that beyond any doubt, and then something more complicated, then something more complicated. It may seem like an extremely slow beginning, but if history is any lesson, Given that Galileo did that in the objective realm, maybe we can play Galileo in a sense in the subjective realm as well.
Subjects have, so many more dimensions than objects, and one dimension that makes it difficult to study them is the ethical dimension that subjects have. That the ethical dimension, right? If I were to treat this table badly, most of you may not be upset, but if I were to treat, someone else badly, then there's an ethical question that arises. And while I think we can use universal measuring sticks to measure the length of this table, and we would probably all agree what the length of this table is. If I were to, engage in some questionable actions, like if I skipped in line, if I cut in line, would you say that I was bad? If I was really in a hurry and I skipped in line in front of some people, is that a bad thing to do? So, there are so many dimensions to subjects. So what is the simplest, zeroth order approximation to a subject that is close enough such that it is almost object-like, so that we might start with that, almost post-object subject, as it were.
That is an enormous challenge, and the same challenge was also true for objects. It is very strange that Renaissance Europe, and then the time shortly after that, including the time of Galileo, why did science start in Europe? China was in many ways far advanced technologically, and then also in other ways much older culture. The Indian culture was way ahead of the European one for a very long time. Why did none of the other cultures develop modern physics, modern science? My guess would be that they were not as myopic as we were, that it just didn't occur to them to be so narrow-minded and really do these very simple experiments and think you can actually do something with that. Somehow we took that very narrow step and we could build on it. And it seemed ludicrous. If I would have lived in those days, my guess would be that Galileo's manifesto may have seemed absolutely ludicrous. And that is probably what people in China and India thought. But somehow they tried it, and something succeeded. So although I completely agree that it seems that the subject is far too complex, maybe there is some way we can get a handle on it and make a beginning. I don't know, what do you all think about?
Well, they're little hints or teasing odd things you can see about subjects. This will be familiar to my co-panelists, but I imagine everyone here has seen a movie or a play or read a book in which someone's mind is exchanged with someone else's mind in another body. There was a movie with Tom Hanks called Big, and there was a movie about a mother and her teenage daughter recently. And it's an old, lots of bad science fiction books where they put some helmet on the hero's head and on the villain's head and throw some switch and their minds are switched from one to the other. None of us have ever actually run into that happening in real life. And it's almost certainly impossible that it could happen. And yet it's extraordinarily easy to understand intuitively. You hardly have to even explain it in a work of fiction, what that would conceptually mean if Jan and I switched minds and I was suddenly in his body. That makes sense to say that. Why is that?
What is this I? What is this I?
Yeah, why is it such an intuitively easy to understand concept? That our bodies are somehow separate from our minds, our real selves, our personalities. And, you can talk about out-of-body experiences or life after death. Many of those appeal to the same intuitive, almost self-evident to many people, it seems, feeling that there's something separate between the real subject and the physical object, which goes back to a question someone asked before. Now, we could have a whole discussion about why that probably isn't true or is true or whatever we wanted. but it just seems odd. It seems like a little hint. I mean, you were looking for little threads to start unraveling. That's what Galileo did. He said it seemed obvious to Galileo. I mean, in Galileo's day, not to Galileo. It seemed obvious to everybody that heavy things fell faster than light things. And in fact, I think surveys have shown that some substantial fraction, maybe even the majority of people on the street, if you asked them now, if we went outside and said, here's $100 if you can predict correctly, I'm going to drop this bowling ball and I'm going to drop this ball bearing, both of which have negligible air friction, which will get to the ground faster. A substantial fraction, despite Galileo's work, would say the bowling ball, heavier things fall faster, and that's intuitively obvious. But it's not true.
To some extent they do, even though a little bit.
A little bit because of the air friction, and also
in most things, there is a significant difference. So it's
right. If you're not careful,
it is empirical.
But Galileo saw that, well, anyway, maybe we shouldn't go into that. That it was a minor, that to first order, so to speak, different things fall at the same rates, and in a vacuum they do, and so on and so forth. So it was something intuitively true that was false, and so that's the only reason I brought up this thing about mind exchange and something. That seems like something that intuitively ought to be possible, maybe even ought to happen. I mean, it just makes sense. You don't have to explain it to people. Children understand that. Children's movies have that phenomenon. A 6-year-old can understand something which is totally, probably, almost certainly, totally impossible and unrealistic to the extent that we really understand the physical world, and even that we really understand how minds work. But which is not very well, is what we're talking about.
Yeah,
but I'm wondering if that's just an example of some thread you might start pulling on.
I'm not so sure what this is an argument for. I could imagine that both of what you said and what you said, that it's both of these things, the ethical dimension as well as Ed's example. I guess that they both could somehow be also explained or discussed in a standard scientific biological evolutionary story. I mean, it's successful for some species to behave in a certain way with each other, and this brings just up ethics in a certain way. And you could also say that this imagination to be someone different, we've just learned to imagine to see the world from someone else's perspective. And that this possibility to see it that way just biologically had arisen.
Yeah, I think I would have to accept that point. It's not neither of the examples, but I mean, Sukanya should say what she thinks of hers, but I wouldn't claim any compelling evidence in either.
Well, I was just thinking. I mean, I guess one of the reasons we really insist on an ethical dimension for subjects is because we expect subjects to have some sense of autonomy, and we, I think, are shocked at instances where subjects act in a way as if they're not autonomous due to some environment they happen to be in, like due to peer pressure, or some of these famous experiments that have been carried out where somebody is instructed to shock somebody behind the screen, and they keep on doing it just because someone in charge has been telling them to do it. So they're not acting in an autonomous way. So
hypnosis, even where
or under hypnosis, and so it seems that the deviations from autonomy for subjects are related, to the environment. I mean, there seems to be some kind of entanglement with the environment, whereas objects will, if I throw this thing, I know, it's not really. I mean, there are, of course, environmental effects like air pressure or friction or drag. But those aside, I mean, to zeroth order, there isn't that much of an environmental dependence on the behavior of objects, on the dynamical trajectories of objects, which subjects seem to have.
One of the areas that I think will be interesting and related to this is that of cloning. And if at some point it becomes the practice to clone humans, and you are able to start doing experiments with creating individuals that are really identical. If there was some way to sort of separate out the environmental differences between any two people, would you end up with the same person? Would could my consciousness inhabit more than one body if I had
at the
a
same
clone
time
of myself sitting right here? Or would we still be individuals in spite of, as much biological identicalness as you want? What is this I? It's kind of back to Jan's original question of what am I?
I mean, mathematically, it's much easier to solve problems in a local manner, right? When the trajectory of a thing doesn't depend on its environment. But when there are many dependencies from the environment that influence the trajectory of that thing, and there are cases in physics where this happens, then it becomes, even mathematically, and not that that has to be necessarily the formalism to use, but even mathematically, it becomes difficult to solve that kind of a complex problem. And the way that subjects interact, like their trajectories, seem to be very much dependent on their environments and their prehistories.
Talking about environment, at some point we were asked to throw the floor open to the questions of anybody here, but we also decided that before we go to the general questioning, I think all my peers were needling me yesterday to try and introduce some sort of very simple type of experiment. A little bit about what I could imagine would be the equivalent of Galileo. And I was sort of hesitant since I said, well, I mean, there's all these psychologists around and, and in a big group it's more difficult than one-on-one or in a small group. But anyway, let me try something. So let me go back to William James. William James talked about how remarkable it is that we can talk about an object like a table here in front of us as a material object, and we can also talk about our experience of the table. And how do we experience the table? Well, like this. What is the material object? It's this. So we point to the same thing, whether we point to a table or to our experience of the table. I mean, we can think that experience in our head, but this is what we experience. So William James gave a beautiful, very simple picture, like he often does. That's why it's so wonderful to read him. He talked about two crossing lines. If you have two lines crossing each other, then there is one point where the two lines cross. And the one point, this point is on this line and this point is on that line. But there are not two different points. One on one line, one on the other line. There is one point which is part of this line and one part of that line. And William James used that as an example, saying, this table as an experience for me is the same as the table which I interpret as a material object. I can see the table as material object, and I can see this as a material object, and I can see this as my experience. So an image which came up for me when I thought about this for quite a while was a blind person with a stick. If a blind person comes in and feels all the objects with a stick, then it's the vibration in his or her hand which gives the feeling of the layout of all the objects. And this person, no doubt, feels with the end of the stick in his or her consciousness. But actually the only thing the person touches is this end of the stick, but the person feels the presence of all the other things. So the stick is the mediator which becomes transparent in the experience. So similarly, our experience is the telescope with which we look at the material world. It becomes transparent, we forget about it, and we think we see directly a table, we see directly a wall. And a little experiment you can do is just look at any wall around you, whatever wall is conveniently located. You look at the wall and you sense the sense of distance. You experience the distance to the wall. But then you remember that all of what you're seeing here is also given in your consciousness. So you can look at the wall as the way you see it as part of your experience. And surely your experience has no distance to you. The experience of distance, qua experience, has no distance. So you can just take a few seconds and taste and sense and feel the distance to the wall, and then as a material object, and then sense that there is no distance to the wall as an experience. So maybe we should do that for 30 seconds or so, just to get a sense, and maybe switch to and from the distance to the wall as a material object to the no distance as your very intimate, direct experience of the wall. This is a wonderful group. People are really doing this. I'm shocked.
Well, you told you so.
Yeah, you were right. It's a good idea to do it here. I mean, normally in a larger group, unprepared, without any setting, half the people are uncomfortable and get restless and whatever. But boy, you pick your audience well here. Congratulations.
Your audience picks you well.
Yeah, I guess. It must be an interaction between the...
As you were talking, though, I suddenly remembered that when I'm looking at the table, I don't see the table. I'm seeing the light coming to me reflected off of the table. I'm not seeing the table.
Yeah, there are many layers. The more you think about it, the more you can tease apart the pages. It's like experiences, this wet book which lies in the rain. You pick it up and it seems to be one thing, but then you learn to tease apart all the pages and you see all these different parts.
Mediation is the difficult part. Figuring out what's the stick, because in the experience of the one, you have the pre-existing concept and you immediately put it in the category of the tables and the walls.
Yeah.
But if you're a scientist, you see more.
Yeah, you are both trained to see more, and you start out seeing more because of your training, but then your training helps you to go deeper into it. Yeah.
Maybe you see less. It depends the context of
What you're screening out versus what you're...
Yeah.
So
That too.
selectivity of definition or meaning focus.
Time for questions.
Sure.
Yeah.
I'm usually first, which is not good.
Go ahead. You had a question?
Oh yeah.
Larry Cutler.
Oh, there's
That's my name.
Oh, I'm sorry.
We use this. Would you say that qualitatively, for example, economics is a science, some call it a dismal science, some don't, or say even climatology, meteorology, is that qualitatively different than, say, physics? Because in economics, the subjective factor is very important, that certain classes of people, whatever, will analyze the science of economics differently than others and see something very different. I like what Piet said about groups of people. There's more chance of science. It's been understood by a number of people, and it was very interesting to me. The question, why Galileo? Why there in Europe? Did they discover the telescope or that way of looking at things? And in China and India, they didn't, where the system was different. The system of society was different. The economic society, there was no need at the time, whereas capitalism was arising in Europe. But anyway, my first question is the main one I'm interested in. At some point, or is it already happening, that even in physics, it depends on who's looking at the material. Does that determine what is the truth? Because certainly all of them won't look at it the same way no matter what.
Mm-hmm. Thank you. Well, anybody for the economy question?
Well, we sometimes have said to each other, and has been said, that science is basically a filter on experience that lets, I'm not sure I would say it was the whole of science, but a sort of first step in science is out of all experience to decide some pieces of it to let through, that you then lay on the table and try to, as pieces of a puzzle and try to put together. My impression of sciences like economics is they haven't figured out, what exactly is the right set of pieces to let through the filter, that constitutes their material. And to the very limited extent I understand different parts of economics or different schools of economics, is they're to some extent choosing a different subset of the available information to try to explain or make sense out of or put together into a coherent story. There's a much greater degree of consensus in something like physics about what is and isn't legitimately passed through the filter. I don't know if that's helpful, but that's a difference, I see.
Yeah, I think it's...
Yes, it's easier.
Well,
should I?
I would add something to that.
Yeah, either way, I'm happy if you do it.
Okay. If you don't see somebody.
Okay, fine, sure.
I don't know. I mean, we have more to add to that, but should we just be moving very quickly? Yeah. Did you want to say?
Yeah, I was going to say that I sort of think of economics as really focusing on the demographics of a population in the context of that population, whereas physics does sort of take. Or astronomy does sometimes take kind of senses of galaxies in the sense that we look at luminosity functions and whatnot. But sort of fundamental physics is trying to identify laws that are universally true, not just in the context of a population. So it's not...
yeah, but in economics they do it too. They're looking for laws, universal laws that continue also. Although there's a difference of opinion. It's not
all sciences, though, I mean, it's easy to study things that are far away, and with with astronomy, there's such a separation, an apparent separation between the thing that you're studying and the studier, that it's very simple. I mean, it's a very simple thing. A star is so simple. Well, of course, until you get close to it, then you have to take into account all these other strange little behaviors. But when you're immersed inside of the thing that you're trying to study, what constitutes science? I think that's at the heart of this discussion.
Yeah.
I was wondering what the panel would have to say about more delving into not just perceptually, how do our perceptions of objects differ and inform our viewing of objects, but actually how different frames of reference can actually Einstein showed that space and time are actually have different measurable quantities based on the speed an observer is moving. So what would you guys say about things like time dilation, length contraction, these things that are actually, the subject actually physically constitutes what is observed?
Mm-hmm. That's a great question. Anybody want to pick that up? Maybe the theoretical physicist among us.
He's referring to, maybe you want to explain what he's referring to.
So in Einstein's theory of special relativity, the point is that you exactly know how to translate these different inertial systems into each other. You precisely know if this observer measures this length, then this observer will measure this length. And so if both observers are in the same inertial frame, then they will observe the same thing. And
explain inertial frame.
A frame which moves with a constant velocity. And so this is a very simple situation which almost never occurs other places in science, that you really know precisely how to relate the things to each other. And can you...
But if I may throw in something...
I think I didn't get the point.
I think it is a significant move from classical mechanics to relativity theory, that in classical mechanics the properties of the objects were completely independent of how you look at it. And certainly a property like the length of something or the mass of something. And then in special relativity, if you look at it in a different way, depending on your velocity, you measure a different length and a different mass. So there is more of an observer dependence, more dependence of the subject measuring to what you can measure. But Jan's point is that you can transform them into each other. They are all objectively there, but you have a spectrum of different possibility, and there is a recipe to pick out how the observer influences what you see. But then in quantum mechanics it gets even more weird. There is no single underlying recipe which tells you absolutely for sure what you get, and there is no ontology, there is no something existing there independently. The beautiful picture is by John Wheeler, a Princeton physicist, who came up with the game of 20 questions? 21? 20?
Oh, I didn't know John came up with 20 questions.
Yeah, the game was there before John Wheeler,
okay.
But he used it. It seems to be... See, for I guess the majority of us are immigrants here. The one thing you miss out if you come to a new country is the children's stories and the children's riddles, and suddenly if somebody uses that in the middle of a scientific lecture, you are at sea because you missed the connection. But the game of 20 questions seems to be that a group of people decides upon a notion or an object or a thing, and then somebody comes in the room and has to guess that within 20 questions. Is it alive? Is it not? Is it mineral? Whatever.
Yes, no question.
Sorry?
Yes, no question.
Yes, no questions. So John Wheeler said quantum mechanics is such that nobody in the room has decided what the thing is. Somebody comes in and asks a question, and somebody says yes to the first question, somebody else says no to the next question. And the challenge for the people who are answering is every time to say a yes or no, so that there is at least one object which still can be there. And it's the interaction between the interrogator and the answerers together in a sort of a dance to come to a certain object. And John Wheeler, certainly a very hard-nosed physicist, said that this was a good metaphor for a measurement in quantum mechanics. So boy, there is the real interaction between the subject and the object, and this is one of the things which really needled me towards trying to see what can the role of a subject be in science. But you're right, special relativity is sort of halfway from classical clockwork to the full quantum mechanics.
It was one of the first times that the observer showed up explicitly as a part of the theory. It wasn't very threatening because it included the recipe to switch between observers. So two different observers might see a different mass, but either one of them can figure out what the other one saw by the recipe.
It was an uninvited but well-behaved family member. But then in quantum mechanics, the black sheep came in.
And it gets worse and worse. If you go on to quantum field theory, then you have these virtual particles which somehow at the same time exist and do not exist. So one observer will find a particle and another will find no particle. And if you then go on to quantum field theory on curved spacetimes, then you have this thing which occurs to one observer as a vacuum. So one observer really observes this is a vacuum, there's no particle there at all. And another observer, which moves with respect to this observer, sees there some entities, some particles. So there's really matter that can be transformed completely away by going from one system to the other. And this is much, much harder to understand than
I think if we had a true believer in the Church of Science, they would say we needn't worry about all of this stuff about consciousness and so on. We just keep on this program. It'll get us there. Eventually, it's got us a long way, and that by surprise, someday an understanding of consciousness, time, self, and all of that might fall out of pursuing ordinary physics.
These four folks here, they told me just before we got started that when they were in the train coming from Princeton, I live in New York, even though I work there, when they came in the train from Princeton, they came up with this scheme that they would all transform into hard-nosed physicists and deny the importance of subject and let me hear for myself defend all of them. But unfortunately...
I have to confess and not implicate my colleagues to this.
Unfortunately, they didn't do it. They gave away the... Okay, go ahead.
Do you want to come up to the mic? Because we can't, well, we don't, then you don't come through on the, it's being broadcast, so...
I was getting very comfortable.
I want to change your point of view, but...
That's right.
The question of objectivity is, of course, a fascination as you four are discussing it, and some other commentary, 5 of you actually. It's very interesting. Let me take a couple of things one at a time. In the matter of robotics, I thought that we have astrophysicists and theoretical physicists in our presence, and I was most surprised to hear that this is not a robotic era. My grandfather took ice, put it in the refrigerator, it melted. And I don't. I have a refrigerator. I open the door and it produces ice. If that isn't robotics, I'm not sure what the meaning of the word is in terms of the 21st century. The same is true of a car. The same is true of the trip I just took to China. I was there for a month. And people were using bicycles to transport me in the old rickshaw technique, which used to be done by individuals, not even a bicycle. And they're changing now toward this Western tradition. Now that's robotics. There hasn't been much discussion about that. Somewhere I remember Isaac Asimov and I, Robot, if I'm reminded correctly. And in that we had the ethical issue raised about what robots may do and what they may not do, raised by you. So there is a history here to robotics that, did you really just go past it, was my question, and not recognize that, in fact, we live in a world of robotics. But that's not the essential point to me. I was remembering the question of objectivity in the way that we discussed it many years ago when I was a youngster in school. And it had to do with the color red. There just seemed to be an agreement that whenever you see that color, you agreed to call it red. Is it red? Or is it blue? Well, I learned when I was a boy that it was red. Every time I saw that color, it was red. Now, the Frenchman calls it rouge. And German calls it rot. So I don't know really what to do with that in terms of language. But the point to me is that's an agreement. That's all it is. There is no objectivity. There is an agreement to call it objectivity. It's once removed from objectivity itself, as far as I understand what the meaning of the word is. I offer you those ideas as a way of into this question, which is very difficult to have at. I'll leave it right there. Those are some observations on the conversation.
Thank you for this question, which helps clarify exactly the terms we use. And because I brought out robotics, let me answer at least that part. What I mean is that with a robot, I mean something which has a certain autonomous behavior, more or less like human beings. It doesn't have to be as complicated, but something like that. You mentioned the refrigerator. If you switch it on, there is one thing it can do, lower the temperature. So in that sense, it is like an object, like a machine. And a car too. If you ride a car, there is a human being, the human subject, using the car as an object to drive around. At the moment, we don't have an autonomous car which can drive around by itself. And people have been talking about it for a long time. They are working on that. I visited Stanford a few months ago, where people are preparing for a race. I think it will be next year or the year after that, where they have a car in traffic, completely autonomous. And sorry?
They're doing it today.
Today? Already? Really?
Right now.
Boy, well, I mean, the beginning of the robotic era is today. What?
I would say it's the beginning of the robotic era.
What good?
You just said the beginning of the robotic era.
I think this is a little bit of a red. This is a little bit of a semantic issue.
No, the autonomous car, that would be like what I would call a robot, at least a good step forwards towards behaving like a subject. Well, we'll see what happens. I hope nobody gets killed in the process.
Will it count if the car gets killed?
That would be a subject.
Maybe if the brain of the car.
Yeah, I have a question, Piet. Ed, you've got to help me here. We had a roundtable that Akil Bilgrami did on subjects and objects. And one of the points of the roundtable, not the conference on norms, but before that conference. And we are at least on the third floor of an analytic institute, so one of the ideas here is to study subjectivity. But the point he made is that in the process of studying a subject, you make the subject into an object of study, and hence it can no longer be the subject. Do you recall? Do you want to say something about that?
No, he's a philosopher.
He's a philosopher. So
it's an extremely important point. Yeah, it's an extremely important point, and I could say many things about it. But does anybody want to respond to this?
Well, I have a similar feeling. I have the feeling that as soon as you start to study the subject, at least if you do it in a scientific way, then you turn it into an object. I mean, it becomes something that is studied. It is an object.
But I thought what you just said about quantum mechanics eliminates that distinction.
What did I say about quantum mechanics?
You said you see it here, and you see one particle is there and then is not there. So it's the subject who determines that what is seen as an object.
But the object there under study is the quantum state, and the quantum state, which is the object under study, can have two different aspects. It has the aspect of a particle being there and has the aspect of a particle being not there. And only the result of a specific single measurement can you give you two different results. But the object is the same in both cases. It's a quantum state.
Is it the reality of the state, or is it the reality of the subject who's observing it?
Well, that's hard to distinguish. I mean, you can ask this question, is the reality of the table, is that the reality of the table itself, or is it the reality of me observing the table? It's the same question, I think. You don't need to get to quantum mechanics for that.
Well, if I can throw in one thing. Then I did this little experiment, and I'm curious whether somebody wants to talk about their experience with this little experiment. There is the wall which is separated from us as a material object. There is the wall seen as an experience. But if I had more time, and it's tempting, then you could do yet another experiment in which you then look at the wall as your experience and you as the experiencer, and try to see, is there a witness who is witnessing the experiencer polarity? And you will notice that there is a witness. And then what do you do with this witness? And that, is it an infinite regression, or you can keep that in the palm of your hand at the same time? Can you wrap your mind around it? Whatever metaphor you want to use. We always use bodily metaphors for the mind. So there is a whole interesting range there. But let me, yeah.
Okay, I have more like a comment. As I'm sitting and listening, what I've been thinking about, it almost seems like the subject is a collection of objects, and the only way an object can become a subject is if they have enough collective things to be enough collective objects to be a subject. For example, the autonomous car. As close as it comes to the subject, that's when it's no longer an object. The table, for example, just has legs like the subject, but that's about it. So it still remains an object until it has more collections to make it more like the subject. That's sort of my comment about it.
A very interesting observation. Anybody who...
Well, it's reminiscent of a phenomenon, fairly new concept in physics called emergence, which refers to the fact that, well, it's difficult to describe, I would say, but we can see in some very specific hard-nosed examples of physical systems sort of the sum being, the whole being more than the sum of the parts. Essentially that you can accrete slowly individual components that behave very simply and eventually, or even identically, and eventually emerge with properties which don't seem to be there in any of the individual components of the system. I'm probably trying to explain this too abstractly, but it could be that you can imagine something like our autonomous car, where if you looked at any piece of it, it would be behaving like a really simple circuit or a really simple mechanical device, and yet the whole thing might be capable of behaving much more like a subject. So the property of being a subject could be, one speculation is that it's an emergent property of systems, so that even though you can tease them apart into little pieces that are behaving like objects, that you put enough objects together, which is what you said, that you get subjectivity, so to speak, emerging. And I think that's a plausible speculation. I don't know how one would argue for it more at this point than saying that it's possible.
Yeah, one thing I would just add to that is, in terms of properties that subjects seem to have that objects don't, especially as a collection, is the idea of memory. If a car, in some sense, has some memory, and it went through some experience of being hit with a stick, and if it sees somebody running at it with a stick, next time, hopefully, it will speed up and go away.
If it hits really bad traffic, it might take another route next time.
And that's something that subjects have, and we have memory, and we react to our environment in a way that is determined by actions that we've experienced in the past, and that's one reason it's very difficult to study subjects.
You can't really take them apart and still have them work as subjects.
Right.
Yeah, my point is a bit different on that. So I feel more on the side of the reductionists, and I'm not so happy with the concept of emergence in general. But so what you find is that you already start from the point that the subject consists of objects, so you can decompose it into objects. And when you do that, or if you do that, then you find that you need all these little pieces playing together in a certain way. But you already assume that you have an approach where the subject is decomposed into objects. And so I think at least some of us ask the question, can we have a different perspective on the subject in which it isn't decomposable at all from the beginning?
And I would add, there is also a big cultural difference. In our culture, we tend to have a sense of a core self. The core self is responsible, it can be good or bad. We have our whole cultural focus on that. If you go back to the Greeks, if you have an inspiration, it's not your inspiration, it's the muses whispering in your ear. Or if you do some bad actions, it could be a god or a demigod or whatever influencing you. Actually, most cultures have the idea that if people do suddenly strange things, it is a spirit occupying them rather than they having a unit core self which does everything. It may be partly the 19th century romantic German influence of the notion of a genius who is this single entity which comes up with this wonderful idea rather than the person being the crossroads of all the influences around them. So I would say to look at a subject as a whole bundle of influences is something which in some other cultures is much more normally done than we are used to, I think. Yeah?
This is sort of just a general comment on things that have been said, and has to do mostly with subject matter. I think you could say that the subject matter of biological science generally resists reduction into analyzable components, and organisms are objects that are generally larger than the sum of their parts. But biological science has gone in a lot of different directions, and genetics tends to be closest to the traditions from physics, I would say. But we've been talking most about about the physical sciences, astronomy, and other things. So I'm just wondering what happens when you change the focus of subject matter, and then how does that affect what you call a subject or an object?
My very short answer would be, in physics you only have a course, and in biology you seem to have a goal. Even a bacterium has a goal, wants to get food, but I don't know what.
You know, I think, well, in my own thinking about, looking for life on other planets and being faced with this question, well, what is life and how will you know when you found it, versus some non-living thing. Really, I feel this need to sort of break out of the mold of wanting to put things always in categories and at least try to think more in terms of continuum and, where, at what point does a collection of things become a life form? I mean, I don't know the answer to that question, but there may not be a point at which that happens. There may be something that's more analogous to a continuum, but I don't know how to explore that further in any concrete way.
To go back to something that Turner said about maybe one way of beginning is the systematic study of subjectivity. And that sort of brings up the issue of neuroscience and beginning to understand consciousness. And I guess my question is, isn't that right now the most fertile area to begin the study of subjectivity? Because if you're talking subject and object, and subject is a human observer, then you've got to understand what his or her subjectivity is all about. And again, it's obviously a very, very complex thing, but wouldn't you want to start there? And in starting there, wouldn't you do it, again, in a scientifically empirical basis, as opposed to, as Jan said, studying the whole? Because do we know any other way of knowing and understanding other than to take that first empirical step, as we would perhaps in basic neuroscience, and then trying to understand how it all works together to create consciousness?
I'm sure that we can learn a lot from this neuroscience. I said in the beginning that the subject is already under study in that way. And it's an important thing to be done, and we learn really a lot of how our brain functions, how we function in that way. But so one point that comes into my mind when I hear of these experiments in neurosciences and so on is that I feel that I would like to distinguish between consciousness and the information content that can be extracted from that. And my feeling is that the neurosciences study only the information content that can be in some way extracted from the consciousness, but not not the consciousness as a, how to say it, as a vessel itself.
I understand that. I guess my question would be, is there a possibility that through neuroscience, and combined perhaps with other areas of science, whether it's particle physics or what have you, that we can ultimately get to the point where we understand how it all comes together to create consciousness?
It's difficult. So I think that from studying the TV program, you cannot learn how to build a television monitor.
Maybe if I could say one thing about that as well, there was a reference in a previous question about comparing our internal experiences of the seeing the color red, what's sometimes called qualia. So if we put a piece of paper on the table that has some color that is the one we all agreed to call red when we were growing up and learned is called red, and we could have various red objects and everyone would agree on exactly what was red and what wasn't red. And let's imagine we added to that a complete success of your research program. So you could say what neurons were firing with what intensities of, our cones and rods, and exactly how it was being processed through our neurons, and what chemicals and what voltages, and everything was there, perfectly described at a physical level. And then someone stands up and says, but is your subjective experience of red the same as my subjective experience of red? And how could we find out if they're the same or not? And clearly just agreeing that we both call that red because we learned that whatever internal sensation we have is the one we're going to assign the word red to. Philosophers have worried about this a lot for a long time, thought about it in great detail, and the general conclusion is it's no help at all, any of that, in determining if we're having the same internal subjective experiences. Neither the fact that we can learn to agree to label them, or that we knew that there was the same physical process going on inside our brain. You might assert that meant we were having the same sensation, but demonstrating that seems to be beyond our grasp. And to me at least, that's...
As he said, it's only 400 years old.
Yes. Well, there is that. But that's what, at the beginning, when I talked about some of the... Well, anyway, that's why I think some of us feel that line of attack may not eventually get us there. But it does lack a certain faith. So, yeah.
My question is, earlier you were talking about how science leaves out two important aspects, which is time and consciousness. Something that really fascinates me is the RNG, the Random Number Generator Project, where, for instance, events like the tsunami and 9/11, 2 hours before the event even happened, they were registering huge changes in consciousness. So this idea of time sort of moving in two directions, like there isn't this linear progression of time, it's almost these reverberations backwards. And in Eastern religions, there's this idea of the timeless now. And I was wondering, how do we go about even starting to prove this, that this could be a possibility?
Well, let me admit a dirty secret of physics, which is that the equations of physics don't have causality running in one direction. We impose that on the equations afterwards. If you look, the most famous example is something called retarded and advanced potentials in electromagnetism. But let's not get into the technicalities. Maxwell wrote down a set of equations. They are causally symmetric in time. Causes run equally, or a better way of saying it is not that there's any motion at all through time. There isn't in the equation. They just impose a self-consistent, solutions of those equations are self-consistent in time in both directions. So anything that happens at any point in time has to be consistent according to those equations with what happened at other sets of time. Now, if you impose the idea of a moving now, then you get causality, but it comes equally from the future and the past. So what it literally says in the textbooks, what we do is we discard one set of solutions. They're there mathematically, and we say they're physically meaningless, which is the ones which carry causality from the future into the present. We just throw those out. And it works that way. There have even, so it's not as though there's nothing already in the technical content of science that might give you some hope of the future influencing the present, as far as the technical equations goes. That said, I have to say that these, I don't know much about them personally. I don't think there's any general acceptance in the scientific community of the validity of these so-called random number. I don't know too much about it, but essentially they are looking for disturbances in sequences of random numbers, anomalies that sort of come before major world events. That if that were to actually be the case, it would be extraordinary and surprising, I think, by our current perspective. But anyway, there's no, one of the problems is there's no real distinction between the past, the future, and the present in fundamental physics. And it's a huge failure. as big a failure as you could possibly imagine in our description of the world to leave out something so fundamental, in my opinion. Maybe other people would.
Yeah, I agree with that.
Thermodynamics, reversibility, isn't that impossible to take entropy and stuff like that?
It's a statistical argument. I mean, if you have initial conditions which are very far from equilibrium,
that's the point.
Then the next moment it will go to equilibrium if you go forwards in time. If you would go backwards in time and you start with that unlikely one, it would also go to equilibrium. So if you wait very long and you get a strong fluctuation, then in both directions of the hill you would go downhill. In both directions entropy would increase. But normally the chance that this thing would suddenly fly to the ceiling because the molecules from below would hit a little bit more often, which is physically possible, is so small we would have to wait much, much longer than the age of the universe for this to randomly happen. But strictly speaking, it is possible. So there is a distinction between what is statistically likely and what is the underlying laws of physics.
A very shorthand way of saying that is it's not an asymmetry in time in the basic equations. It's in the conditions of the system you're applying them to.
It seems that our universe is one where the well-ordered, for some reason we don't understand, the very well-ordered initial conditions have been set in the past, whatever that means.
It has something to do with the origin of the universe.
Well, in the Big Bang, I mean, the Big Bang was relatively simple, and space and matter together expanded. And then structure formed by gravitational clumping. So it started with very little structure, and more structure is forming. And all our breathing and working and doing is all increasing of entropy from sunlight being converted. So basically it is the present of the Big Bang which we are still unwrapping as if we are under a Christmas tree. And all of our life is the unwrapping of the present of the Big Bang in terms of the ability to increase entropy. That is one way of summarizing that. But what you said about time, if you look, for example, from a Buddhist point of view, there are at least some branches in there, some schools, which indeed talk about a fourth time or a different type of time. And in fact, many contemplatives and many traditions talk about a different way of experiencing time. I mean, and poets, if you read William Blake, when he talks about seeing the world in a grain of sand, he also talks about time clearly as a different experience. And if you go back and if you say, what do I know about the past? What do I know about the future? All my memories are present memories of the past. And all my expectations are present expectations of the future. So everything we do is that even if there is this timeline with past and future, in this point now, in a way, we construct an orthogonal timeline in which we say, in the present, we consider a past and we consider a future, and we deal with that in order to hopefully say something about this postulated past and future of physics. But we never have access to either of them. The only thing real is the now, with the present memories and expectations. And in a physics point of view, the now is a vanishing moment, and everything else is the large, overwhelming reality. So these two realities are, in some sense, almost literally orthogonal to each other. And it is a very interesting question whether poetic, contemplative, whatever experience you have if you're in a musical jam session or whatever, in which the sense of time is different, whether that will ever lead to an extension of science which can really say something about it. My guess would be yes, but my other guess would be that it might take a few hundred years, and we may not be there to wait for it. But I see no reason, with all the changes in physics in the last 100 years, I see no reason that in the next few hundred years we might be able to come to grips with a whole different way of dealing with time.
Yeah. Hi, Karen Rude. In this discussion, you've been grappling with the terms subject and object and describing characteristics, or trying to both these terms. As humans, do we use the human mind as our standard for what a subject is? Or do we go beyond that?
What is the human mind, I think is my question. That makes it different from mind in general.
Well, we are.
I mean, there you go.
We are humans, so we need our alien expert to help us.
But is subject equivalent to the mind, or are we talking about something beyond our minds?
I would say the other way around. I think the mind could go beyond the subject. I think the subject is already a certain way in which the mind constitutes itself. It relates itself to the rest of the world. But I could imagine that a sort of mind is possible for which the subject-object distinction doesn't even occur, maybe. But a subject is a certain way in which the mind constitutes itself.
I mean, I don't even have any way of knowing whether, the person sitting next to me is really conscious. All I know is my own.
Shall I tell you?
Oh, but that's just because of the molecules of whatever that you did that. I'm the only one. When I was little, I used to wonder this. So many of the things that we're talking about today really came to me as a child to think about. Is anybody else here really real, or is it just me? Am I the only one who's sitting here having this experience as what we're referring to as a subject, and everybody else is just machines or something? Or what is it that
it could also
how could I possibly know if there's another kind of consciousness even in another human, let alone something non-human?
But you do things by analogy, right? I mean, insofar as I admit myself as a subject, I think I would be willing to admit you and other people as subjects in that we have similar behavior, and even possibly robots as subjects, if they're able to learn, process information. If they behave in some analogous ways to me that that are different from objects like computers, which just take inputs and give outputs. So I would, make a distinction between computers and robots in that way.
We are the standard. Robots resemble us, so then they are subjects.
Right. I guess one way to proceed, that's not necessarily the only way, but one way to proceed that might be useful is to proceed by analogy with something that we do understand, which is ourselves.
Yeah, I'm not sure it's so trivial. When you have a dream, then there are also all these other characters around you, and you would also suppose, they look like me and they are all real, and in a sense they are all real, but they are all certain facets of yourself in the dream. So that was what I'm going to say. It could be that all the other guys are also just you.
Yeah, and I wonder, as an astrobiologist, thinking about life in the universe again, I wonder, could a star be alive? Could a star actually have a consciousness of some sort that, maybe is totally different from mine, and so communication is kind of hopeless other than that it's shining light at me and therefore I can learn things about it. But how would you even begin to approach that other than from your own,
It's probably worth mentioning that in many non-scientific cultures, it's considered intuitive that what we would call objects have spirits associated with them: rocks, trees, caves. Kami in Japanese. They have some sort of subject within them.
Early on, someone said that there were things that science doesn't know. And I think a more interesting question is, are there things that science cannot, or human beings cannot know? And it seems obvious to me that if you think of evolution and the mind has evolved, that some of the things you're talking about today are just beyond the machinery in our brains to know. We know apes, lower animals wouldn't be able to understand this. So why presume that we can understand these great questions?
Or how do you know that apes and lower animals don't understand this?
Because of how they change their environment, what they do,
but
the way they behave.
Yeah, but how can,
they don't know how to build houses.
Are you measuring that by building? Oh, okay, so building buildings, that means then that...
Well, all the things that human beings do, we've learned to do, but it seems like there should be limits on what we can do. Maybe something will evolve from us. We're not the end of the evolutionary chain, so something will come along to us and think of us as lower animals. And how could they understand these things?
Well, we even know at the level of mathematical proofs, thanks to that troublemaker Kurt Gödel, who's hails from Piet's institution, that you know, there are true things that we can't know to be can't prove to be true in a mathematical sense.
Well, I was thinking more of things like, you know, you had mentioned this concept of time, for instance. You know, the idea of like, the Big Bang, or what came before it, or the idea of time is so built into our existence. You know, things become before and after that. I don't see how we're going to ever understand like what came before. Or is there an end to the universe? If there's an end, what's beyond it? I mean, these things are just, I think, my feeling is that they're beyond machinery in our brain to ever understand.
Well, what are the limitations of our brain in terms of understanding?
Or how does brain even have anything to do with understanding? I mean, it's like if you have a brain in a jar and it's alive, is it conscious? Does it have understanding?
You know, I think consciousness is one of
if
these
you
things.
did, if you did, would it be conscious?
If you did?
Yeah. If you had a living brain.
If some hands were pots and pans. If, why do you say
Yes.
if? You can imagine anything.
Is a brain conscious?
We can't find out back to the beginning. But, well, in sympathy with that comment, we certainly all believe our bodies have limits. You know, we can't lift an infinite weight, you know, an arbitrarily large weight or run arbitrarily fast. So there might be other limits.
Or is familiar with the biological progress that's been made in neurophysiology, embryology, neuropathology, all of these things. Can't doubt, it seems to me, that is to say, the only logical conclusion that one, or the best logical conclusion that one can draw, is that mind is one aspect of the functioning of the forebrain. You can't prove it any more than I can prove that you exist, of course. You can't, there's no proof. That isn't what science is about, it's proof. What science is about is what is the best logical, non-magical, and so on, conclusion that one can draw from the available, relevant data.
You mean emotions are not contributing to mind?
Is that what I said?
You said the forebrain, emotions are mostly midbrain.
Well, in the first place, I don't believe that that's so.
But but you don't believe it, okay.
All right. But even if it was so I say the central nervous system.
But yeah. I guess what you are saying is to say that if you put somebody under general anesthesia, they don't have a mind at that point.
Absolutely.
That's an observation. Like if we cut our head and we may jump around for about 5 seconds, but then we pass out.
They did that. They actually did.
When I was a little boy, they would bring the chickens in the street and they cut their heads. They jump a bit and then they
Yeah, sure, they run around. But Ed, of course, it's on the basis of observation that you draw your conclusion.
But I guess when people are looking at other evidence for life in other places, I would imagine they must have a much broader concept of what these things could be than what we imagine in our own narrow, small world.
You see, the question was brought up, what is life? Does it start at a certain point in complexity of macromolecules or not? That's the question you brought up.
I think, well, that's one of the questions that we... I'm not sure that I necessarily want to limit myself, a priori to a discussion of life in terms of macromolecules or molecular arrangements. And it's where do you start from? Is there, where is mind possible? And is it really just a certain, is it carbon, is it organic molecules arranged in a certain way that create mind? Or can mind be manifest in different ways? So,
perfectly legitimate question. I would say that the evidence, the available relevant evidence that we have, is that mind is an aspect of the function of the central nervous system.
But can I answer to this? You could also get the precisely opposite conclusion. You can say that obviously we can observe brains, right? And so the brains appear in our mind. When I observe a brain, the picture of the brain is present in my mind. And I could draw from that the conclusion that the brain is one aspect that appears in the functioning of my mind, which is precisely the contrary conclusion to what you said. And Erwin Schrödinger...
You're talking in paradoxes.
That's a lot.
That's science.
If you prefer paradoxes to logic, okay.
no, that's not. How is that a paradox? What he
I
just
don't
said.
understand why this was a paradox. I mean, the brain appears in my mind, so the brain is a part of the...
Brain appears in your mind?
Yeah,
yes.
the brain. When I observe a mind, the picture of the brain appears in my mind.
In his consciousness.
What is a thought?
That's a difficult question. I can't answer
An
it.
impossible question. You can't answer that question.
I can't answer the question.
What is meaning? Because we're talking and we understand each other, right?
Mm-hmm.
We know what the meaning is. If I say it's very different from if I say how are you.
I think what Jan's trying to point out is a symmetry we
I can
impose
say
on
it myself, yeah. So there was one point...
This was his mind speaking.
Right. There was one important point, I think, made by the physicist Erwin Schrödinger, one of the founders of quantum mechanics. He said the one thing that bewilders us about the mind is that on the one hand, it is the vessel, the stage on which this whole world process takes place. There seems to be no world without a mind. And on the other hand, it seems to be so clearly completely dependent on these small little organs, the brains, which somehow by these evolutionary processes came up in a rather chance by chance process. But there is a duality is maybe not the right word, but you can see it from two sides. You can see it from the side that the mind is the vessel and the brain is only one of the things that comes up in the mind. And you can see it the other way around. The mind is the stage on which the world takes place.
Maybe if I can tell a little story. The story about why computers compute. And the reason that the computer can compute in such a wonderful way is because of the blue smoke which is circulating inside the computer. I mean, that is clearly why computers compute. And the proof of this is that when, at any time, blue smoke escapes from your computer, it stops working.
You can talk in paradoxes if you want.
But like all life
You can believe in magic if you want. So perfectly, it's an attitude, an explanatory attitude toward the universe, which is widely accepted by millions of human beings.
But Charlie, the way you are expressing it, essentially what you seem to be doing is closing the door to any further development. Because in order to be open to further development, you have to allow all sorts of other possibilities.
Well, which ones do you allow?
All of them. There's no reason. You can allow magic. We've seen some magic that has altered our perception of the world completely. And the magician is sitting there.
But then, my point is that when you say science or scientific, you're saying, I think that the best way to understand the universe about me,
today at 5:45.
At 5:45, Eastern Standard, Eastern Daylight Saving Time. Eastern until tomorrow.
That's true.
That the best way to understand it is by not believing in magic, by drawing the best conclusion that you can, best logical conclusion that you can, from the available relevant evidence. That's a definition.
Sure, but we're taking the same observations and interpreting them from a different standpoint. And how do you decide which one is the preferred standpoint?
I'm not saying standpoint, I'm only saying that's a definition of science.
Well, maybe a way of saying something about this is that you're asserting, I think, that the preferred scientific direction is to explain the consciousness, the mental world, from a materialistic basis, and not explaining the material world from a conscious mental basis. And if you will let me try to see where you get it, you were just pointing out that those two are symmetrical in some sense. They're an arbitrary choice. And like particle wave duality or something, it could be that there's something to both of them. It could be that one of them is more.
Choice. Any definition is an arbitrary choice.
Well, maybe we are well over the 2-hour limit, which was given to us by the organizers, so maybe we should stop.
Thank you very much.